So when you're solving linear inequalities, you treat them just like equations or solving linear equations in that you were trying to get the variable by itself on one side. There's only one thing you need to keep in mind, and that is if you ever have to multiply or divide by negative, you must switch the inequality sign. That's it. Question?
Yeah, I have a question about when you have to switch the inequality sign.
Yes.
If you have like an equation like number 8 that has 2 of them and you were to divide, you have to you switch both of them?
You switch both of them.
Okay.
Yes. So, number 7. Pretty easy. We're trying to get n by itself, so I'll subtract 1 for n is less than 8, and then divide both sides by 4. I did not multiply or divide by a negative, therefore I do not switch the inequality sign. So the values of n that make this a true statement are all values that are less than 2. Okay? Now we're asked to express it in interval notation. A volunteer, please. Brett. Parentheses. Negative infinity. Comma 2. Parentheses. And then Brett, the number line. What do I put on it?
I use 0 and
2.
and then an open circle on the 2.
Open circle on the 2.
And then forever to the left.
Forever to the left. Hopefully it's coming back to you. Any questions on 7? Number 8 is an example of a compound inequality. You can think of this as two simple inequalities. For example, negative 2 is less than 5 plus 3x, and 5 plus 3x is less than or equal to 20. You could solve each of those, but if you want to be quicker about it, you can just do them both using this format here. If you're going to do that, then you want to get x by itself in the middle, and any algebraic operations you do, you must do to both ends. Anyone think that they could do this? Allie?
Okay, you subtract 5.
Subtract 5.
And you get 15 and negative
15 on the right,
yeah.
and negative 7.
Equals, is then 3x in the middle.
3x in the middle.
And then you divide by 3 each side.
Good. Divide everything by 3. So you get
Negative 7 over 3
negative 7 over 3
is less than x,
is less than x,
which is less than or equal to 5.
less than or equal to 5. And the interval notation, please.
Parenthesis, negative 7 over 3,
Mm-hmm.
comma, 5 in bracket.
Very good. And the number line.
Negative 7/3 and 5. I didn't shade everything in between, but on the 7/3 side is open circle up, and on the 5 sides is
Very good. Okay, any questions on 8? Number 9. Another volunteer? Yes?
On 8, why did you not use the infinity signs?
Because the question is, why did we not use the infinity signs for 8? Because the interval is bounded on both ends. What this is saying is that all values of x between negative 7/3 and 5, excluding the negative 7/3 and including the 5, are valid values.
So if it's an n problem, you wouldn't use that.
Usually. Yeah, I mean, I really have to think to find one that doesn't. Okay. Again, volunteer for Niner. Dan?
Shouldn't multiply -4. I mean,
Yeah,
multiply -4. Yeah, it's by itself.
good. So we're going to wipe out both the 4 in the denominator and the negative sign in one step by multiplying both sides by -4.
Don't you have to switch the inequality?
Nice job. We have to switch the inequality because we are multiplying or dividing by negative. So tell me what you get.
Yeah, x is greater than x negative
Very good. And Dan, the interval notation?
it's -36. Like the square bracket.
Bracket,
Yeah.
-36,
comma,
comma, infinity. Yeah, close paren. Okay, and pretty sure you can do the number line, closed circle at -36, shaded to the right. Any questions on 9? This is a compound or inequality. So you solve them both. Now, it's pretty simple. Here we just add 4. You get 3x is less than 4, and then divide both sides by 3. I will leave the or in there. Over here, we're just going to do what? Yeah, Nikki. Divide by -1. Just very good. Just keep in mind that you must flip the inequality sign. So we get 2 is greater than x, which is the same thing as saying that x is less than 2. So this is an interesting situation because what we're saying is that x can be less than 1 1/3 or it can be less than 2. And if you analyze that graphically, there's no point in doing both of them because it's an or situation and one includes the other. So if you just say that x is less than 2, that's going to encompass the fact that it could also be less than 4/3. So this is kind of a strange or inequality, but anything can happen. Question, Gabe?
But since the x is less than but not equal to 4/3, should you exclude the 4/3 from the...
Very good question. We do not need to exclude the 4/3 because this is an or inequality, meaning that either this or this can be true, and then the whole compound statement is true. The fact that x can be less than 2 covers this. Okay? So we just need this. If you said both, it would be redundant. That x is less than 4/3 or x is less than 2. No need. So that's going to be paren -infinity to 2 paren. Let me give you a counterexample. Let's say this -2 was a +2. So we'll say this is 10a. Well, same thing on the left. But on the right, you would get -2 is greater than x. And actually, I think that's the same problem. Let me revise it again. Let me change it to x is greater than 2. Just so that you can see the difference. So what that looks like is an open circle at 4/3 and to the left, and then an open circle at 2, and then shaded to the right. And then the interval notation would be negative infinity to 4/3, parentheses, and then union, parentheses, 2 to infinity. Just so you can see what one of those looks like. Okay. So it's just like one of the ones on the first page. Okay. Yes, question?